Hello guys and welcome to ZappySys 101. In this video you will learn how to generate a complex XML using SSIS. You will find this video helpful if you want to export data from a database or other source to an XML file, another database, or submit that XML to a SOAP web service or XML-based API. ZappySys PowerPack provides these components to deal with various XML generation scenarios: Export XML Task, XML File Destination, and XML Generator Transform. In case you are watching this video but want to read XML files, use XML Source component or XML Parser Transform to parse XML from upstream column. Use Export XML Task when you want to export XML from a database with great performance. Export XML Task supports SQL Server or any other database that you can connect to using ODBC or OLEDB drivers. You can export XML to a file, Azure Blob Storage, Amazon S3 Storage, SFTP, or FTPS. With Export XML Task, you can export a table as is with minimal configuration or export to a custom layout XML. XML file destination is very similar to Export XML Task, except that it can accept anything from upstream in a data flow and then save an XML to a file. XML file destination as well as Export XML Task and XML Generator Transform, which I will speak about in a moment, all support multiple data inputs. It means that you can have, for example, customers as one input, orders as another, and then join these two on a key to write customers with all their corresponding orders as child elements. Finally, use XML Generator Transform when you have data coming from upstream in a data flow and yet you still need to pass the generated XML downstream. For example, you want to generate an XML that you need to save to a database or submit it to an XML-based API. Let's get started and see how to generate an XML file. In this part, I will show how to generate quite a simple XML file. In the next part, we will construct a complex XML. To start, create a new SSIS package and drag and drop Export XML Task from SSIS Toolbox into the control flow. Then double-click on Export XML Task for editing. First of all, you will need to create a connection. Select either OLEDB, ADO-NET, or ODBC type of connection. We will use OLEDB connection. Once you have created the connection, you can simply enter the tables you want to export. Separate table names with the pipe symbol or check the example below to see how to select tables for export using a pattern search. You can also exclude tables or views from pattern search. Using customers pipe orders %, will export 3 tables as is, each to a different file. However, if you need a custom XML layout, you will need to use Custom Layout option. Let's say you have the table orders with this data and want to produce this kind of XML. XML's outer element is request. Import orders element has a static attribute version with value 1.0. Within import orders, there is a static element add only with value true. Then orders element embraces all order elements. Each order element has an attribute ID with its actual ID. Inside each order element, you have all the details of an order. To begin, go to tab Custom Layout. Check Single Dataset Array. I will explain why we need it in a moment. Right-click on Datasets and click Add Dataset. Enter a dataset name, row element name, select the connection, and table orders. You can also use a SQL query to define a dataset. If your SQL query is dynamic, then you can use an SSIS variable. In this demo, we will use a table. Right-click on Mappings and select Add Unbound Nested Element menu item to add XML element named Import Orders. Right-click on Element Import Orders and select Add Attribute to add version attribute. Once the window appears, select Add Static Value option and fill in a name and a value. Again, right-click on Element Import Orders, but this time select Add Static Value element to add add-only element. Then fill in a name and a value. To add orders, under Import Orders element, once again right-click on Import Orders and select Add Document Array menu item. Now we can get back to Single Dataset Array option. By default, Add Document Array requires two datasets, parent and child, which we will use in the next part of the video. Thus, we needed it to produce an array of elements using just one dataset. To proceed, enter orders for element name and order for row element name. Now, right-click on Item Orders and select Add Attribute menu item. This will add ID attribute. Select Order ID as source column and then change output alias to ID to match the name of the attribute. It's time to add order elements. Right-click on Orders and select Add Element. Use Add Multiple option and select the required columns. To change ordered on node's name to match the one in the output XML, right-click on the node and change the output alias to date. Now go to XML Options tab to update order date format. The last modification we need to do is change root element's name to request. Among many options in XML Options tab, you can change file encoding or character set, do not output properties with null value, and do not output XML declaration node. With Export XML task, you can split output XML. Just go to Split Options tab and enable the option to split by file size or by rows number. Finally, go to Target tab and select the target destination of your XML. You can either directly enter a path into the text box or select a variable which is set to a path. You can also use a target connection. Using a connection enables you to save to a flat file, Amazon S3 storage, Azure Blob Storage, FTPS, or SFTP. In this scenario, we will use a direct path. Export XML task also supports overwriting target file, appending to an existing file, or compressing a file. Let's open destination folder and execute the task. Finally, let's compare the generated XML with the result we expect using Visual Studio Code, a popular text editor. As you see, both XMLs are identical. This concludes Export XML Task demonstration and how to generate a simple XML file. In the next part, you will learn how to use XML file destination to generate a more complex XML file. In this part, you will learn how to generate a complex XML using XML file destination. So let's say your XML consumer's system changed, and now it requires to submit you a different kind of XML, this one, instead of the XML we generated in the previous part. So the main change basically is the added namespaces here, some attributes, XSIS schema location, and then the orders are generated in the XML a bit differently. So as I mean, in the original video, whereas we had orders listed under orders element and they just go as a list, here we group them by customer. So a list of customers basically is generated, and within each customer you have the orders. So 2 orders for Sports Arena and 1 order for John Doe. So in the original XML we also had Sports Arena 2 customers, 2 orders for Sports Arena and 1 for John Doe. So same goes here, except that it also has a name here. So to group the orders by customer, we will be using this customer table, and we'll be joining this ID, customer ID, with customer ID on the orders table. Then within each order we will list data basically as usual as in the previous XML. The only difference is that we will have this unbound nested element order data, which will encapsulate total and comment element. I think we can proceed now. I will put it in here so we can compare it later with the result we expect. Minimize these. Okay, and we can start to create a package. So first of all, drag and drop data flow task, double click it to edit. Now let's add all a DB source, one for customers, the other is for orders. Double click it to configure the table. Let's select customers and select orders. Okay, now we can add XML file destination from SSIS toolbox. Now connect customers with XML file destination and orders with file destination. and do it in this order, because when you connect customers with XML file destination, customers will be a root data set in XML file destination. Here you can see it. Okay, let me open the desired XML we want so that I have an example. Okay, so to proceed, you will need a connection. So create a connection to a file, complex XML, output XML. As you see, XML file destination supports overwriting target file or appending to file just as export XML task. It also has this output mode with 3 options. I will use output one XML document for all records. That's what we need, and I will explain about other options in the next part of the video. Okay, so to start, we can add the namespaces first. So let's do it. To add the namespaces, write data here because we have data here. And yeah, and the namespaces are prefixed with XML and S prefix, except this one, so this item. Okay, so now let's copy. Use a comma to separate the namespaces. Then we will need to copy the shop namespace. We also have this SSIS schema location, but it's not a namespace, it's just a simple attribute. And this one will be added automatically, so we don't need to do anything. Okay, so what's next? We also need to change the root element name. So instead of root, just enter a request and the shop becomes the prefix. We will also won't have this XML declaration node, and we want to modify the date format to match the desired format. Okay, we are done. Okay, now let's add the first element customer so that some example shows here, a preview. Right click and select add unbound nested element menu item and write customer. Don't forget the prefix data. Click OK. Okay, so now we have the preview. Almost all request attributes are here except schema location. So let's copy the value which we will use in the attribute. So right click on mappings, click menu item, and then add the item itself. So it will be XSI prefix, and don't forget to use add static value because it's a static value. The name is schema location and the value is this. And the most important thing is check add to root node, and it means that the attribute will be added to the root node instead to the dataset row. Yeah, and click OK. And as you see, the attribute was added. Yeah. Okay, we can move on. Okay, so the next thing is that we have to add the ID. Right click on customer, add attribute, and select the ID. Click OK. Then the next thing is we need to add the name. and here comes the name. In the preview, as you see, we have a little problem here because the element customer is surrounded by this row element. So to fix that, right click on the root dataset, click edit, and then in the row element name just delete the name, and this will remove the row, the parent row. Okay, once that's fixed, we can add the orders. To do that, go to data customer, right click on it, and select add document array. Enter the name for the orders order, select the order dataset, and let's give a row element name order. Now let's join the parent dataset with child dataset. So we're using ID for parent dataset and customer ID in child dataset, just as you saw in the SSMS. Okay, let's join these. Click OK. Nothing happens because we still have to add the elements and attributes, etc. So to add the ID from here, right click on orders, select add attribute, and select the order ID. So let's change the output alias ID to match the XML name ID. Okay, so we are now ready to add the date. Right click on orders again, select add element, and select ordered on column, and give the appropriate output alias, which is date. What's left? It's order data. So let's go to orders again, select add unbound nested element, and give it the same name as you see in the XML, order data. Okay, now we are ready to add the child elements to order data. Select add element, choose add multiple bound option, and then select the two columns. Click OK, and the child elements are added. Now there is still one problem here, is that order elements are surrounded by this parent element orders, and we need to remove it. So to remove it, right click on orders and select edit, and then hide only parent node. Select this option. Then click OK, and that node disappears. Okay, I think we are ready to execute the package. Let's click OK. Let's restore our destination folder, and let's execute the task. Okay, yeah, so as you see, 2 rows come from customers and 3 rows from orders, just like we wanted. And let's open our generated XML. Let's format the XML, and now let's compare it with the result we expect. Let's select this output XML for comparison, and let's compare it. So as you see, both XMLs are identical. So this concludes the XML file destination demonstration and how to generate a complex XML file. In the next part, you will learn how to use XML generator transform to pass the generated XML downstream. In this part, you will learn how to pass the generated XML downstream and submit it to an API. So we start basically where we left with XML file destination demo, but I just exchanged and I replaced XML file destination with XML generator transform. You can find it at the end in SSIS toolbox. And yeah, so what I did is basically I copied the mapping code from XML file destination. I pasted it here using this edit code button in editor, and then I modified input IDs to match the new ones. Okay, so to submit, what we are going to do in this video is submit XML to an API, and we will be generating one XML per customer. So XML generator transform provides us with this option. There is this option output mode, and you can generate XMLs using several ways. So one is output one XML document for all the records. Then we have output one XML document for each parent record, and also we can output it as a single dataset array. So we used the first one in our last part with XML file destination, and as the name suggests, one XML for all records option will produce one XML for all the records. By default, elements added under the root node, like here, right, get repeated with each dataset or upstream row. So all of those elements will be saved as one XML. Then we had a single dataset array, which we used in export XML task. And this single dataset array option enables us to stop repeating parent elements, and also let us produce an array using just a single dataset. So it also allows us to batch XML elements. So instead of generating 1000 XML elements, you can generate 10 XMLs with 100 elements each. So for our case, we will need to generate an XML for each parent record, and customer is our parent record because it comes from the root dataset. So we will be using this option, and before moving on and showing you actually how to submit XML to an API, let me show you a couple of options you can use. So for that, let's add another element, name. It should appear, yeah, it appears at the end. Yeah, right click it, click edit, and here you have a couple of options. So one of them is output as CData section. So what it basically does is that it encapsulates your data in CData section, and you can have any characters you want in that data, and they don't need any they don't need to be escaped. Yeah, and there is another option, XML treat value of this column as raw XML fragment. It's the same thing as with CData, except that it doesn't enclose your data in in anything in CData section, it just takes your raw value and put it into XML. So you can use this option, let's say if you have a column and which holds, let's say, XML fragment in those less than and greater than angle brackets, and you can check this option, and then those less than and greater than symbols won't be escaped. So basically your column will be treated as XML fragment. Another option is hide from output and include columns in downstream output. So use these two simultaneously if you want to output a column side by side with the XML generated. So I will check this and I will show you how this column will appear as input in another component. Okay, so yeah, we can move on, and now I will show you how to submit to an API. Let's drag and drop web API destination, connect it with the generator transform, right click, edit. Then you will need to create a connection. I have a predefined one, so just to save time, and you can watch our other videos which discuss this topic in detail. So here you see, so to select the input column for body, select this ZS XML out, and this name is that other column we included downstream. So let's take this ZS XML out. It will be so basically this column will hold like two XMLs, I mean row by row, and then yes, and that's it. This has to be posted here. Yeah, okay. So we are expecting two XMLs to be submitted into an API. Let's open Fiddler, a popular web debugger. It allows us to see what requests are being made to any of the websites. But before capturing the traffic, let's go to Options, HTTPS, to enable to capture HTTPS traffic. Click OK. Let's start capturing the traffic. You can also press in here. And now we are ready to execute the package and see what requests were made. Okay, so we have two requests, one for each customer. Select Inspectors tab and Syntax View subtab to see what was the actual XML that was submitted. Let's right click and click Format XML. Let's also open an XML that was generated, and as you see, we have here orders for customer sports arena, right? So just like in our generated XML using XML file destination. So same two orders, and in the customer we can also go to subtab XML, so it shows a bit a more user-friendly view. So again, customer ID SA, just like here, sports arena, then two orders, and date and order data, well, basically all the same things. Then if we went to the second request, it's the request made for John Doe. So order for customer John Doe was submitted, just like in the original XML. So this completes XML generator transform demonstration and how to submit XML files to an API. Concluding today, you learned how to generate XML files using export XML task, XML file destination, and XML generator transform. We went through how to construct XML, add XML elements, attributes, and arrays. We also covered namespaces, datetime format configuration, and other advanced options. You found out how to output XML in different modes, split it by size, rows number, or compress it. You learned that you can save the output XML to a file, SFTP or FTPS, Azure Blob Storage, Amazon S3 storage, or submit it to an API. We also touched how to use Fiddler to debug HTTP requests. Thanks for watching, and don't forget to check out other ZappySys 101 videos.